I am stuck with wedge force pulley problems. And they are coming in exams, so I need help with that.
I'll help you first go through the basics of forces and how to identify them. All
Okay.
right, and then using some few examples, I'll teach you how to apply that in some problems. So let's quickly first brush through the basic concepts of forces, kinds of forces, how are they represented, their directions, etc., and then we'll use them in problems.
Okay.
So I've uploaded an example on the whiteboard. You should be able to see it now. So let us see how to apply the concepts which we have learned previously into this problem. And you need to find the tension in the string. On the first block, which is the 20 kg block, okay, let's identify and indicate forces on the 20 kg block.
Yeah.
Okay. Now, do you remember was the second force?
Normal force.
And it was in what direction?
It's perpendicular to the surface of contact, so it should be upwards.
Very true. So perpendicular to the surface of contact, upward direction, right?
Yeah.
Now tell me, why is it not in downward direction? Because downward direction is also perpendicular. Remember, the reason why it is upward and not downward is, and see, we have written that,
It's a push
that the direction and the nature of this
It's
is
a push
push.
force.
So push here is upward.
Upwards.
Right? Got it? What is the third force which we saw?
Tension. I guess it's already drawn on the string, so tension in this
Yes.
side.
Yes, the tension in the right direction. Very true. And the fourth force which we saw is friction.
Friction.
Now this block 20 kg has a tendency to move in the right direction, right? That is why the friction is opposing the relative motion, hence it will be applied in left direction.
Left direction.
True? Right? So that is why friction is already indicated, is drawn in the left direction, and the value is
FK.
indicated as F. Okay? So any doubts in the forces?
No, nothing.
No. Okay. Now let's come down to the second system, the 3 kg block. Okay. Now similarly in the 3 kg block, because there is a mass, there will be an mg, is already indicated as m into g, which is 30 newtons.
Yeah.
Alright. Now, is there any contact surface here?
No.
There is no surface which is in contact with the 3 kg block. Hence, there will be no normal reaction. Third, tension. Yes, there is a string, and as indicated, tension will be a pull force.
Yeah.
So, pulling it upwards along the string, upward direction.
Yes.
Okay, and no friction. So, there is no frictional force. Alright. Now, so the only thing now remains is how to find the value of tension. Okay, because this is what is asked. We need to find the tension in the string.
Yes.
So very simple. Let's find the values of all the forces here. Now the friction, as indicated as Fk, friction is denoted numerically as mu into n.
Into n.
Right? So we'll write it here. Fk is equal to mu into n. Now, how much is? Let's also look at the acceleration of this. Now, as indicated, the acceleration of this block will obviously be in the right direction, and this will be in downward direction. Right? So, for the 20 kg block system, we can easily write that tension minus Fk, right, which is 8 newtons, is equal to mass into acceleration. Yeah. This is my equation number 1. Alright, and for this 3 kg block, I'll write the downward force, which is 30 newtons, minus upward force, which is tension, is equal to mass into acceleration. This is my equation number 2. Alright, so if I add equation number 1 and 2, can you tell me what happens? So can you tell me what is the value of A?
A equals to 22 by 23.
Very right. Approximately 1. Okay. Now, we'll take this acceleration and get back to this equation. Alright?
Okay.
Okay. It is first equation is t minus fk is 20a. So a, if I approximately put it as 1. Alright. So let me just write it here. So tension minus fk. How much was fk?
8.
Is equal to 20 into 1, which is 20. So can you tell me how much is tension?
28.
Right. So tension is equal to 28 newtons. Got it?
Yeah.
Okay. Now, since you have understood how to solve this, I'll give you one more example, and I'll ask you to identify the forces on the system. Okay?
Yeah.
Sounds good?
Yes.